Hello everyone, I hope you're doing good this week. You'll notice Beaker's not with us today because, well, he's still acting a little strange. Okay, what is going on? I'm not Beaker. Okay, while I try and figure out what's going on here, please enjoy this lesson. Hello everybody, we're going to be taking a look at part 3, which is naming ionic compounds with polyatomic ions. First thing you need to note is, remember, we've already got these two ideas. Number one, we have ionic, which has one set of naming rules, and covalent, which has another set of naming rules. If you see a polyatomic ion, it's automatically got to be ionic. So he just uses, there are no new rules. If it's polyatomic, we use the same rules as the ionic naming. A polyatomic ion is a clump of atoms that are all held together. When we start to name things, we have to treat the polyatomic ion like it is one thing. We don't treat it as the separate elements that make it up. You'll see in just a moment when we look at some examples of polyatomic ions. They all have special names. You have a periodic table of ions, which has all those names on it for the ones that you need to know. Take a look at this chart. Again, this chart's not as important as the periodic table, but if you ever see NH4 in a formula, we don't call it nitrogen and hydrogen, we call it ammonia. If you see, take a look right here, SO4, now the -2 is just the charge, but if you see SO4 in a formula, we don't call it sulfur and oxygen or sulfur oxide or anything like that. We call it sulfate. So you've got to watch for polyatomic ions. Now, your life is pretty easy because we're only doing binary substances. So if it's binary, it can be ionic or covalent. If it's got more than 2 atoms in it, then you know it's got to be a polyatomic ion, and you're going to use the ionic rules. Now, you have this periodic table, and this box right here are all the polyatomic ions that you have to know, or you don't have to know, but these are the only ones that you will ever use in any problem in our class. So when you see any of these things in this box, any of these are the names that you're going to use for them. So when you look at a formula, you've got to name. Look these over very carefully. If it's more than 2 atoms, you know there's a polyatomic ion. You just have to find it on the chart and write down the name. The rules for naming ions with polyatomic ions are the same as naming regular ionic substances, so nothing new to add here. Let's take a look at an example. If you see NH4, C2H3O2, well, this has way more than 2 atoms. Therefore, we know there are polyatomic ions involved. We just look on the chart. We find NH4, that's ammonium. We find C2H3O2, that's acetate, so this is ammonium acetate. Here are some examples. Pause the video and see if you can work these. Once you've got your answers, restart the video and we'll check your answers. On the first one, NaOH. Obviously, we have more than 2 atoms involved, so there must be a polyatomic ion. And when I look on the chart, we'll find OH, and so this is sodium hydroxide. MgNO3, 2. This 2 is not part of the naming thing. All we have to worry about is the Mg and the NO3. Again, we know Mg is magnesium. You look on the chart and you see that NO3 is nitrate, so MgNO3 is magnesium nitrate. NH4, 2, SO4. Remember, these little symbols here, these little subscripts, they're not actually part of the naming thing. So when I'm naming this, I just need to look up NH4 and SO4 on the table of polyatomic ions, and I'll find that that is ammonium is NH4, and sulfate is SO4. Now be careful about the 8s and the ites. Some of them are different on the chart, so double check those carefully. Now, this one has two parts we have to worry about. Number one, iron has multiple oxidation states. So you've got to check and see what Roman numeral goes with iron. And then we need to look on the chart and see what this polyatomic ion is. So we look up iron, and then we check the charge on this ion, and that tells me what the charge had to be on the iron. And so this is iron 3 phosphate, because phosphate, PO4, is a -3. So, taking a look real quick, this is a little flow chart. We'll have this flow chart again a little bit later on in the week. I'll send it out to you as a document. But you're just simply going down the chart. Is it binary? If the answer is yes, well then you're just going to use normal rules. It's just normal ionic or normal covalent. If it's not binary, that means there's more than two atoms involved, then you're going to have to use the polyatomic ion rules. What is the name of KClO3? Well, obviously not binary, so we have to look up ClO3 on our chart, and that is potassium K, chlorate ClO3. Now this one's a little tougher. You've got a chart with 4 substances and their names associated with them, and the question is, which of these is named correctly? Which of these is named correctly? Well, the only one named correctly is 1. This is diphosphorus pentoxide. This is covalent, and we use prefixes. ClO2 is also covalent, so prefixes should have been used. PbI4 is lead iodide, except lead has multiple oxidation states, so this should have a Roman numeral. And this is not copper 1 sulfate, but copper 2 sulfate. You have some sample problems for you to work today. If you have trouble with them, please feel free to email me. Thank you. I hope you found that informative. As for Beaker, Misty's going to have a little chat with him, and I think he'll be better by the next time we talk. Quick reminder, this week will be the last week of instruction before spring break. During spring break, there won't be any lessons posted or any more activities for you. If you are behind during spring break, I will still be checking my email and checking Remind. I don't think I'll be sending out anything. But if you need help or you have a question during spring break, you can always get back with me. As always, be smart, be safe.